Hello viewers, welcome to Emmanuel Maths Academy. We are still in differentiation. In the last video, we were able to look at differentiation, the basic method of differentiation, the general method, which is the power rule. And we also were able to look at sum and difference rule. And also we're able to look at the product rule, where we said that we use product rule or the product method of differentiation where two functions are multiplying each other. And now, what if we are given a function like this? You have something like this. Maybe x raised to power 3 plus 2x all over what? X, right? What if you are given something like this, a function like this? How do you go about this? Basically, you may think that you have to separate this thing first. Maybe you separate this to get x power 3 over plus, okay, over x, 2x over x. Now I have what? X power 2 plus this, you cancel this to get you 2. You now differentiate using the normal general method, right? What if you are given a case where you have this all over x plus 1, something like this, x cubed plus 2x all over x plus 1, or even x plus, or even maybe x squared plus 3x minus 1 also. How do you go about this? You can see that this is more complicated, right? How do you go about this? What if I tell you that there is a method, or there is a rule that which can use to solve something like this, and that method is called what? Or the technique is called what? The quotient rule, or quotient method, or quotient technique of differentiation, right? Well, first of all, what is quotient? What is quotient? Quotient means it's just like a result which you get when you divide two numbers. When you have the quotient of 4 over 2 is what? 2. The result which you get after dividing this is your quotient, right? The quotient of 12 over 6 is 2, right? The quotient of maybe 9 over 3 is what? 3. Is that correct? So on that note, we use quotient rule when we have two functions dividing each other. When you have a function that is dividing each other, you use what? Quotient rule. Is that clear? Now you say let u and v be differentiable function of x. Now let u and v be differentiable function of x given by f of x equal to u over v, right? Now remember that this u is a function of x and v is a function of x also. Prime, which is the derivative of this, which is equal to what? Dy dx is equal to what? V du over dx. Keep v, or write down v, what you have in your denominator, then differentiate u with respect to x, minus keep u, differentiate v with respect to x, all over v squared. Is that correct? Now this thing can be rewritten. You can write this as what? Maybe f prime equal to what? Y prime. You keep v, differentiate u with respect to x, u prime minus u v prime all over v square. It's still the same thing. It's still the same thing. Is that correct? So now, when you are given a function dividing each other, what you have in your numerator, the up one, is your u. Then what you have in the downside, the denominator, is your v. Then you write down the v. You now differentiate u with respect to x, right? Minus, you write down your u, differentiate v with respect to x, all over what you have in your v power 2. As simple as that. Let's solve this using this method. Let's assume this is an example. Now, let me write this thing out here. Plus 2x all over x2 plus 3x minus 1. Right? Your y is this. Find the y, the x. Now, solution. Solution. Your dy dx is what? You keep v. This is our u. This is our v. You keep v. X squared plus 3x minus 1. You differentiate this with respect to x. X power 3 plus 2x prime. Right? Minus, you write down u. Is that correct? X power 3 plus 2x. You differentiate this with respect to x. X power 2 plus 3x minus 1 prime. All over what? All over v squared. What's our v here? X power 2 plus 3x minus 1. All power 2. Is that correct? Now, dy dx now is equal to what? X squared plus 3x minus 1. You now differentiate this. If you differentiate x cubed with respect to x, what do you get? You get 3x power 2 using the general method, right? This x, if you have x, y equal to x power n, you have that your dy dx is equal to n times x power n minus 1, right? This is what we are using, the general method, right? You use the 3 to multiply the base, you subtract 1. Is that correct? Here we have what? 2x minus x power 3 plus 2x. You differentiate this, you get what? 2x plus 3 all over what? X power 2 plus 3x minus 1 power 2. Is that correct? Let me clean out this. It's just like an illustration of how we did our simple differentiation. Now, to simplify further, dy dx is equal to what? You use this to open up this. That's first to first, first to second, and first to third. Right? Using, just expand this using binomial expansion. You use this to multiply the first, use this to multiply the second, use this to multiply the third. You now come back with the second one. Use the second one to multiply the first, use the second one to multiply the second, use the second one to multiply the third. As simple as that. You do the same thing here. But let's start with this. We have, if this should multiply this, you have what? 3x power what? 4 plus 9x power what? 3 minus 3x power 2. Right? Plus, you now use the second one to multiply this. You have 2x power 3 plus 6x power 2 minus 2x. You now use this. Oh, remember there is minus here. Right? Use this to multiply this. You have 2x power 4 plus 4x power 2 plus 3x power 3, right? Plus 6x all over what? X power 2 plus 3x minus 1 power 2. Is that correct? Now, use this minus to open up this, right? You now have that dy dx is equal to 3x power 4 plus 9x power 3 minus 3x power 2 plus 2x power 3 plus 6x power 2 minus 2x minus 2x power 4 minus times plus minus 4x power 2 minus 3x power 2 minus 6x, right? All over what? Our v square, x power 2 plus 3x minus 1 all power 2. Can you see this? Can you see this? Now, you do what is called collection of like terms. You collect like terms. Like terms simply means taking or bringing together the terms or the numbers that have the same term, that look alike. In fact, just the simple meaning. The numbers that look alike, just bring them together. You have x raised to the power 4 here. You have x raised to the power here. Bring them together. Add them together. You now have x raised to the power 3 here. X raised to the power 3 here. Add them together. That's all. That's what we mean by collection of like terms. Those that look alike. As simple as that. Now, you can decide to leave your answer like this, but to simplify this further, you have that your dy dx is equal to what? 3s power 4 plus what? This minus this, you have x power 4. S power 4. Right? If you have this plus this, you have 11s power 3. Is that correct? You have this. Oh, sorry. This will not cancel. 3s power 2. You have minus 3s power 2. Right? Minus 3s power 2. I will also have plus s power 6. Okay, minus 3s power 2 minus 3s power 2. You have minus 6s power 2, right? So if you are having minus 6, this is minus 6, right? S power 2. It will cancel out this. Is that correct? Now, how many power 2 are we having here? We are having only 1 power 2. Right? You have minus 4x power 2. Now, for x, you have minus 2x minus 6x, which is equal to what? Minus 8x. All over what? X power 2 plus 3x power 3, 3x minus 1 raised to power 2. Now, this is your dy dx. This is the derivative of this.